No, and all that, they don't help me. Look, it's like it's those and nothing else. Those help me, and so I was like, talking about that, and, okay, well, I really do not,
All right, as for today, we're doing the last bit of chapter 5, and this is everything for the midterm. And the last bit is division. So right, we did addition, subtraction, multiplication of polynomials, and the last bit is division. So we're gonna start off with the simple one, which is dividing a monomial, a single term, into a polynomial. With this is just like those rules of exponents. So you basically take it one piece at a time. The divisor goes into each individual piece of the numerator, just like with all numbers. Then it's just a matter of simplifying it down and using those rules of exponents. So if I have a 4 divided by, and what is x, what power is that in the denominator?
1.
1, right? These are all to just the first power. So when I have x to the 4th divided by x to the 1, what do I do with those exponents? Yes, and do what operation? Subtraction, right? So it's just 4 minus 1. So this becomes 1/3 x to the 3rd. All right, since that is a 1, x to the 4th. 15 divided by 3, do the number, so that's a 5. X cubed divided by x to the 1st, x squared. 6 divided by 3 is 2. And x squared divided by x to the 1st, subtract those, x. So a monomial, a single term, all right? You just do the rules of exponents piece at a time. And that's essentially what we already have done, all right? We're just doing that in more steps. The real interesting part is dividing polynomial by polynomial. In order to do this, we need to actually remember our rules of long division, all right? So it may have been a while. Couple of terms, all right? Divisor is the piece on the outside, dividend, all right, or the radicand, right, is the piece underneath. We take that, you take it in one piece at a time, right? Multiplying and subtracting. We're going to do an example. So let's do 3 divided into 720. I don't want this to come out. I want a remainder. 721. Okay, so with this, all right, so we're going to do this slowly so we can refresh on our rules of long division. What do we do first?
3 into 7.
Go 3 into 7. And you say, how many times does 3 go into 7?
2 with 1 left over.
Twice. Okay, so we're going to do this slowly because we want to make our analogy to polynomial division. Then what you do in your head is you do a side step. All right, you say 3 times 2 equals 6. Then what do you do with that 6? Subtract it. You bring that over and subtract it. That then leaves a 1. Then what do?
Bring down 2.
You bring down the next number. All right, then we do it again. Say 3 goes into 12, how many times?
4.
And so then you say 3 times 4. And you bring that over and subtract it. Then lastly, you bring the last number all the way down. And you say, how many times does 3 go into 1? 0 times. So what does that 1 become? All right. The last value becomes what we call the remainder. All right, but in polynomial division, we don't just say it has a remainder. All right, if I want to write the exact number, what number is this? 1/3. So that remainder actually becomes, all right.
Put a 0 in there.
Well, 1/3, 0, 0, 1/3. The 0 was just from the subtraction above, right?
220. This 240.
The what?
All right, you're good. I thought it was, you have to put the 0 to say 3 goes into 1 0 times.
No.
Because 3 times 24 would be not 700.
0.
By the 4, would it be?
Oh, is this 240? Oh, you are right. Ah, see, that's why I wanted a 1 there. Yes, has to be 200, 240 and 1. I wanted another number there with the polynomials, yeah, because you're right. 24 times 3 is, 60, change, 70. So yes, so it goes into 0. All right, then the last number comes down and that is the remainder. So yes, 240. All right, and 1/3, that's the big value there. So polynomials work the same. All right, polynomials, we have to do this process of long division with the side step, and it becomes even more important because the biggest thing is the subtract step. That's why we do the side step. I know we keep track of that very easily, all right, when we have values, all right. The other thing, descending order, highest power to lowest power, write any missing terms, all right, and continue until we, basically the degree, all right, of the remainder is lower than the degree, all right, of the divisor. So let's do an example. So I have this first one, x cubed plus 1 divided by x plus 1. The big part here is now I need to add in all the missing terms. So, all right, whatever power, whatever degree you start with, make sure you have all degrees all the way down to x to the 0. When we do this math, all right, so we still remember our steps of long division. We still say, all right, x times what makes x cubed. So you kind of ignore the +1, all right, and all remaining pieces. Just look at the highest degree of your divisor, all right, and the highest degree of the polynomial. So x times what makes x cubed?
X squared.
X squared. All right, now you don't have to worry about lining it up exactly here. It's not like the numbers. All right, so then we do our side step. And I say x squared times x plus 1. Now you have the whole thing. All right, it's what we did with our 3 times 2. Multiply that out, x cubed plus, so we're just rainbowing, x squared. Now, what did we do with the side step in long division? We subtracted. So you bring it over and subtract, but one of the things, because now I have 2 pieces, when you bring this over, and the easier thing, and flip the signs. Mostly because this is where people really mess up, because if you just say subtract, a lot of people write it like this, which seems correct, right?
Wouldn't it be a negative?
It's actually that. right? So usually, in order to save yourself the hassle, whatever you have over here, flip the signs, and especially when one starts being positive, one starts being negative, we're gonna see that on the other ones, all right? To save yourself the trouble, because you have to rainbow and then subtract as you're bringing them down. And that tends to be the issue, all right? So bring it over and flip the signs. That's gonna be our strategy. All right, so the first term goes away, and it always should. The second term then becomes negative x squared. Then what did we do?
What goes into negative x squared?
Drop the next term down. Now, here's the best part. With polynomials, you drop it all down. So you don't have to just drop the next term. It all comes with you, so you're always working on the lowest step. Then you do it again. X times what makes negative x squared?
Negative x.
Negative x. Then we do our side step. And this, see, now we got negatives. This is why when you bring it over, I'm gonna bring this over and just flip the signs immediately. So whatever you wrote over here, the signs should be opposite when you write them. And then subtract it down, and again, that first term should always disappear. If it didn't disappear, all right, either you're at the remainder step or you messed up your side, what you should have multiplied by. That becomes x, then it drops down again. And then x times x, x times what makes x?
What you flip both sides.
So if the remaining value is 0, then there is no remainder, which means that multiplied exactly or divided exactly. All right, let's do a bunch more of
Can I
these.
see your last side step on the?
Okay, yeah.
2x plus 3. Okay, so this one, I didn't have to fill in any missing terms. Cube 3, 2, 1, 0, right? So I have all the powers there. So that's always what you want to make sure. And always, again, descending order, 3, 2, 1, 0. Want to make sure that I have everything, right? And it is in descending order. Then we do it again. 2x times what makes 6x cubed?
3x.
Almost. 3x squared. Have our side step, and again, this is why I bring it over and flip the signs. It's almost always this first step that gets the most messed up. Everyone knows that this should go away. But if you forgot to flip this sign in addition, right? So you would have had negative 5x squared plus 9x squared, and all of a sudden then every step from there on is messed up. So both signs flip because again, it is quantity, all right, subtraction. That leaves negative 14x squared. And what else do we do? Bring it all down. And then rinse and repeat. 2x times what makes negative 14x squared?
-7x.
Negative 7x.
X. Plus 21x.
Then what do we do?
Sign.
Flip the signs every time, both of them.
So plus 14x. 8x plus 13.
And one last time. 2x times what makes 8x? 4.
Just 4. Yeah, just 4.
And that's the other nice thing, right? When you do the side step, if you guess that number wrong, when you rainbow this, you're doing the multiplier. So you know that that number has to match exactly this number, right? What you end up with in the side step has to be your term, right, that you were looking for. Because the opposite sign, it shouldn't be the opposite sign, because the opposite sign of that term, when you bring it over and subtract it, makes it cancel. All right, so 2x times what makes 1?
2x times what equals 1?
Yep.
0.5.
Okay, 2 times 0.5 makes 1, but what about the x?
0.5, half of an X.
I was like an x in the denominator, right? So like, at that point, when the degree of your divisor is higher, what's the degree of our divisor?
1.
1, x to the first power. What's the degree of the remainder? 0. When the degree of the divisor is higher than the degree, all right, of whatever is remaining of your radicand, all right, that means this last piece is the remainder. Now again, we don't just call this the remainder. This is what I was talking about with the fraction.
Be 1/2.
That's exactly what it is. 1/2x plus 3. All right. You end up with a fraction. Now be aware that up here, right, we had 240 1/3. Remember that this actually means 240 plus 1/3. So we're writing the same thing, okay? We're writing the same thing, but because we had so many pieces involved here, right, it's just all separated by additions and subtractions. Brad, did you have a question?
Yeah, would you get negative 7x in the size?
Negative 7, oh, right here? So that was this step. And basically I was trying to identify 2x times what makes negative 14x squared.
Okay.
Right, so the number was -7, all right, then x times x makes x squared. You multiply this by something, that's what we're trying to figure out what that something is, to make it equal to that piece of the division.
Okay.
For us, well. Okay.
Okay, couple of notes, all right, about this next one. 14y cubed minus 9y squared minus 8y divided by 2y squared. People see this, right? There, it says division. So we immediately run and write it as such. Very common. But notice the problem we just did, all right, and the problem before. Does it look the same?
No.
What is different? We are doing polynomial division here.
Say two y plus 0.
Yes, so if there's a plus 0, right, it's basically not a polynomial. It's actually back to the very top, it's this. All right, it's a single term, and so people you get rolling in division, and even though it's written, all right, as divided by that piece, all right, that everyone wants to do long division on it. Don't make it harder on yourself. This actually shouldn't be written this way. It should be written this way. Because I can simplify this down much, much easier than doing all those side steps and subtraction and all that mess. All right, the single term divides into each piece. And then we just simplify it and subtract the powers of exponents. So 14 divided by 2 is 7. Y cubed divided by y squared is just y. And then same thing, minus 9/2, I'm just gonna leave it as such. And y squared divided by y squared is?
Y.
What?
It's y.
I mean, it can't, is what you're saying, is it cancels, right?
Sorry.
Yes, it cancels. Y squared divided by y squared is just 1, so that goes away.
Yeah.
And then, all right, I have 8 divided by 2 is 4. And then the tricky one on this, okay, so y divided by y squared, what results there?
Y the negative 1, or you just leave it over y?
Either is acceptable, all right, but the more appropriate way to write it is y in the denominator, right? But you're absolutely correct. I could write this as, since it didn't say requires positive exponents. So I could write this as minus 4y to the negative 1. But most of the time, be aware, our directions say write things as positive exponents. So usually we want to try and write it as like this guy. But the point of this is polynomial division. This is the most difficult part of everything in chapter 5. I mean, we did boxing, you know, we had rainbows, but the many steps that polynomial division requires is usually there's a lot of details involved. So don't try and do it when you have a monomial within the division. Okay, for this guy, when I write this out, all right, 4x to the 4th minus 3 minus x minus 4x squared divided by 2x squared minus 3. What is important when I'm going to be writing out the part underneath the square root?
Descending order.
Descending order. Notice it is not in descending order. Also, what else is a problem there? Missing x cubed. All right, so we got to make sure that we fill it all in. All right, and write it in descending order. Okay, so it's getting it all set up and written correctly. Always the first step. Almost all mistakes are in the first couple of steps, right? So we always want to start off on the right foot. Then we begin. 2x squared times what makes 4x to the fourth?
2x squared.
2x squared. Now, here's the other thing. Notice when I did my side step, I have 4x to the fourth minus 6x squared. Everything is lined up, which means you want to try and line up your terms. So 4x to the fourth clearly goes right here. 6x squared, I wouldn't put that under the x cubed. I want to line it up under the x squared as well. Yeah.
Plus, right? Yeah.
And one more time, let's just emphasize. All right, flip your signs as you move over here. This is when one sign is positive and one is negative. So notice that almost everything we had both same signs. When one is positive, one is negative. When you flip the signs over here, this is when everyone starts getting messed up. Wait, I had a negative, wait. So that negative becomes positive. All right, so flip your signs. Just get in the habit of doing that as you bring it over. Now, here's the good news. 4x to the fourth minus 4x to the fourth becomes 0. 0x cubed plus nothing becomes 0. So both those first two steps basically go away. And then I'm just left with 2x squared. So even though we added in the 0x cubed, we didn't use it. All right, but again, better to have it, not need it than the other way. All right, then bring it all down. And then we can repeat. 2x squared times what makes 2x squared? 1. All right, this is what you were asking about, Brian, right? So I'm just matching those terms, and oh, this is the best case. 1. And again, notice the signs, flipping the signs. So when I line this up, right? 2x squared minus 3 minus x minus 3 minus 2x squared plus 3. What's that only leave? Negative x. And so 2x squared times what makes negative x?
Negative 2.
No, nothing,
No,
because
nothing.
nothing's greater than.
Yeah.
That's a higher power than that, which means this guy is the remainder.
Negative x over 2x squared minus 3.
Wait, Bo, can you explain why we dropped the negative x but not the cubed one? Will you explain that again?
We drop the negative x.
As the remainder.
Oh, well, because this is 0x cubes. 0 times anything is. So 0 plus anything is, oh, sorry, 0 plus 0 is what is missing here. 0 plus 0 is still 0. That just goes away, that goes away, all right? So even though we added it back in initially, we didn't use it, and that happens too. That's why I wanted to show that that's the special case.
Because technically the x has a 1 in front of it.
Oh, yes, this is negative 1x, you're absolutely correct. That does not have a 0 in front of it, that has a 1 in front of it, that has a 0. So, polynomial division, all right, and it can get long, all right? At most, we only had 3 steps. Usually it's pretty done by 3 steps. But like I said, I don't love this graphing. That is all applied. I mean, you can just really do a lot of applications with graphing. Very realistic, all right? Heavy usage in statistics. This stuff, all right, this is uber detail oriented. Signs. We rainbowed, we're flipping signs, we're doing subtraction and then rainbowing again, all right? So this stuff is just super detail oriented and you really have to keep track of each step as you go. What I like much more is synthetic division. Now, polynomial division always works. Synthetic division only works in very special cases. Those special cases are a degree of 1 as your divisor and a coefficient of 1. So notice, if I was dividing by a minus 7 or dividing by x plus 5, that would work. It does not work if I was trying to do, my divisor was x squared plus 6 or 2y plus 6. Okay, that coefficient is not 1. This degree is not 1. So notice, look at these examples. Notice the divisor in every single case. A coefficient of 1, a degree of 1 in every single case. Now, what's in the numerator or what is the radicand doesn't actually matter. This can be anything up there, but what you're dividing by. Now, be aware that what we looked at before. Oh, notice that x cubed plus 1 divided by x plus 1, I can do synthetic on that. So we did long division on that, polynomial division, and now we're going to do synthetic division so you can see the two options. On these other two cases, 2x plus 3, 2x squared minus 3. I cannot do synthetic division on these two. So synthetic division is just a shortcut for polynomial long division. This method always works that we just went through. The method we're about to do only works in certain cases, but once you get the hang of it, it is super, super fast. So that's kind of the advantage of what we're about to do. Okay. So let's start with an easy one. So we have this guy, and here's how the synthetic division works. Only take your coefficients. It still has to be in descending order. So 1, 5, 6. All right, so I'm dropping all the x's, but I still have it in descending order, and if I'm missing any, I have to fill those in too. My divisor is x plus 3, which essentially means you are solving the equation x plus 3 equals 0. That is, use -3. We're doing this because when we bring it over and subtract, this is, quote, saving the step. The other way is just to look, oh, it's plus 3, so I'm just going to use -3. And that's usually the fast way of doing that. I'm going to write that guy here. So notice what we're writing looks a little different. Synthetic division has a different setup. The first step, drop that value down. And basically, this is all about arrows. So the down arrow is a sum. The diagonal arrow is a multiply. What I'm multiplying is I multiply the value I have here, -3 times 1. That then becomes -3. And then we just repeat that over and over. So down means sum, 5 minus 3. And then multiply. -6. So every time, this is the one, this is coming over in every step. Then 6 minus 6, 0. And as soon as you're out of numbers, you're done. When you count it back, it will always be 1 degree less than whatever you started with. But when you start counting back, remainder, the number term, or AKA x to the 0 term, x to the first power, And then if we had more, and we're gonna have more on the other ones, x squared, x cubed, etc. So this becomes, do we see what our answer is going to be? 1 times x, 2 times x to the 0. AKA, it's just the number, 2. And 0, there is no remainder. That is the answer. So the whole point of this is that you drop all the x's and you, right? You do all the quick like math, and then you get the answer at the end. Let's do some more of those to practice. All right, so I have x cubed plus 1 all over x plus 1. So this is exactly the one we did with the polynomial division above. So since we have x plus 1 as our divisor, that means we use -1. So x cubed, x squared, x 1. So we still have to fill in all our missing terms, but you basically just count it in your head. Now let's see if we can repeat. So that becomes 1. What goes right here? No,
-1.
-1. -1 times 1? -1. What goes here? -1. 0 plus -1 is -1.
So 1.
+1. You hate this method?
-1.
Hold on, wait, what goes right here? 1, okay. And then what goes right here? And what goes right here? Notice how fast we can start doing that math, all right? And so when we write this out, again, remainder, the number term, x to the first power, x squared. That means, what is our remaining polynomial? No, what's the polynomial? What we're done with the math. We're done with the numbers. So what's the polynomial?
-1x squared? No, I don't know.
1x squared.
Yeah.
Minus 1x. Plus 1. No remainder. X squared minus x plus 1. Notice what we had above. X squared minus x plus 1. The point of synthetic division now, it only works in some cases, and again, you're not alone, MJ. A lot of people initially hate this. After you do a bunch of these, because look how long these take. And I see so many mess ups with the signs on these, that after you start getting the hang of synthetic division, they just fly by. And here's our last problem here, right? This is where it really starts to show its advantage. Because now I have x cubed, which means this is at least 3 steps deep of polynomial long division. Okay, so x plus 2, start there. That means we use
-2.
-2. Everyone's all over that part. Okay, 6, -8, -14.
6.
One of those was negative, -14, -14.
And -8. Plus 13.
Okay, so first step,
Bring down 6.
yeah, just that first step is always the same too. It drops down. And then you just start multiplying.
12.
12,
-12.
-12, just make sure I heard you correctly.
-20.
All right, hold on, someone, MJ, what goes right here?
Huh?
What goes in this next spot? Negative 20. All right, Bryant, what goes right here?
I'm not for sure.
So the diagonals, they mean multiply, and it's always this piece times whatever you last wrote. So negative 20 times negative 2. So what goes right here? 40, positive 40.
Negative.
Oh, that makes sense.
All right, Fred, what goes in the next spot? The down arrow means what operation are we doing? We're summing. So negative 14 plus 40,
Yeah, -26.
negative 26,
Positive 26.
positive 26. Brittany, what goes in the next blank?
Next blank, it would be the 26 times the -2.
That is correct, which is
Negative.
negative 52. All right, and Maddie. What's the last blank? What operation are we doing?
Well, we're tech adding, but I don't know the.
What two numbers?
13 and -52.
13 minus negative 52, negative 39. And that one, I mean, calculator, right? As long as you know what's happening. All right, so this is the remainder. That's the number term, aka x to the 0, that's x to the first, that's x squared. What is our remaining polynomial state? Kaylin?
6 x squared, as far as I got.
Okay, 6x squared
Minus 20.
minus 20x
Plus 26.
plus 26.
Minus 39.
39 over negative 2.
Oh, yeah.
39 over what?
Negative 2.
Ooh, it is
Oh,
not
yeah.
negative 2.
X plus 2.
Remember, yeah, and that's the trick.
So you're always gonna go back to whatever.
Back to the original function. Because again, the whole point is, that's why it's called synthetic division, right? Think, all right, approximate, right? A substitute, synthetic, right? The point is to skip full polynomial. Now, beware, all right? I say use synthetic division, but if you want to do full polynomial division, that's fine. The idea is synthetic division is half the time or less, all right? So it's always kind of a measure of how fast are you, okay? If you are faster with full polynomial division, more consistent, then use that. The idea is if this really shines when it's something along the lines of like x plus 2 divided by x to the 5th minus 32 all over divided by x plus 2, something like that. X to the 5th, that starts becoming a lot of steps. Okay? That's where this is the type of polynomial where synthetic division really shines, because you just start doing the like very, very quickly. All right? When you do polynomial division, that's like 5 steps deep with a bunch of 5 side steps, 5 bringing over subtraction. The chance you mess up your signs starts to really, really increase. So you want to be able to do both methods. So practice both methods, all right? The activity will, of course, assist you as always. Speaking of, all right, we have our last activity, all right, for chapter 5 right here. So take a look, all kinds of fun stuff.
So.